Hi everyone, this is Amy from the Helms Academy, and today we're going to be talking about prime factors. By the end of this lesson, you'll be able to define the key vocabulary and identify the prime factors of a number. Okay, first, let's figure out the most important vocabulary. A prime number can only be divided by 1 and itself. Here you can see a list of some prime numbers. Most of the prime numbers are smaller, and there are fewer and fewer as the numbers grow larger. So let's take a look. 1, 2, and 3 are all prime numbers, but you'll notice that you don't see 4 on this list. That's because 4 can be divided by 2. 2 times 2 equals 4. You'll also notice that 6 is not on this list. That's because 6 can be divided by 2 and 3. We know that 2 times 3 equals 6. Other numbers that are not on here are not listed because they're not prime. The numbers you see on this list are only prime numbers. Factors are numbers that can be multiplied together to get another number. We said earlier that 2 times 3 equals 6. That means that 2 and 3 are factors of 6, as well as 1 and 6. Okay, ready to practice? We're going to try something called prime factorization, and it's a process that will help us to find all the prime factors of a number. Let's take a look at the number 42 to start. To begin, you can write the number 42 at the top of your paper. Then draw 2 lines like the ones you see on the screen. This will help us to map out the factors of our number. Okay, now we need to think of 2 numbers that, when multiplied together, make 42. I have chosen 7 and 6 because I know that 7 times 6 equals 42. I wrote each of these numbers at the end of each of those lines, as you see here. Are either of these numbers prime? Yes, the 7 is prime. However, the 6 is not. Since the 7 is prime, we leave it as it is. We can't divide it down anymore. But the 6 we can divide down some more because we know that 2 times 3 equals 6. So at the end of the 2 lines coming out of the 6, we'll put a 2 and a 3 to show its factors. Now all of the numbers that are at the ends of lines are officially prime, the 7, the 2, and the 3. So we're done making this factor tree. This means that we've found our prime factors. To identify them, we have to look at where each line ends. 7, 2, and 3. We can make sure we did the math right by multiplying those prime factors together. 7 times 2 times 3 is 42, which is the number at the top. So that confirms that this is correct. One common question is if this only works with certain number combinations. Let's take a look. We'll use 42 again at the top, but this time let's start with different factors, 2 and 21. Many larger numbers have multiple different factors you could choose from, like this. We'll use 2 and 21 because we know that 2 times 21 is 42. So again, the 2 is prime. We don't need to do anything else with it. The 21 we can break down into 2 more numbers. So I think of 7 and 3, knowing that 7 times 3 equals 21. Now 7 and 3 are both prime. So this confirms that no matter which factors we start with, we can still get the right prime factors in the end. So take a look. 2, 3, and 7 are still the prime factors for both factor trees, even though we got them in different ways. Okay, let's look at one other example with the number 81. First, I know that 81 is 9 times 9. So I'll put those 2 factors at the end of each of my lines. 9 is not a prime number, so we need to now break down both 9s. Now, the good news is that once we know how to break down one 9, we'll know how to break down the other 9 too. It'll be the same. And I know that 3 times 3 equals 9, which means that I'm going to break down both 9s with the 2 lines that come down from each of them. And at the end of each line, I'm going to write a 3, just like you see on the screen. Even though it's the same number for all of those lines, it's really important to write them all down because this helps us keep track of all the factors. Okay, now it's time to check. 3 times 3 times 3 times 3 is 81. We got all of the right prime factors. This is prime factorization. Good work today, and thanks for watching. Don't forget to check out the Helms Academy at helmsacademy.org.